This is screencast 5 for week 4, 571. So I've gone over out-of-control action plans, control plans, and some general comments on the use of control charts. So the last thing I want to talk about for this week is autocorrelation. In control charts. Well, what is this? Auto is a Greek word for self. Automobile is self-mobile. Autocorrelation, therefore, must be something like self-correlated. So you've got yourself a time series. Say x bar in time. I thought this was subgroup. Well, it's the same thing. I is a subgroup, and each subgroup is acquired at a particular time point. So you are monitoring along, and you notice that the data looks like this. Kind of smooth, but not really trending up or trending down. This is a sure sign of positive lag 1 autocorrelation. It's a dead giveaway. Smooth. Smooth time series. And what it means is the two random variables at I and at I plus 1, the correlation between x bar at I and x bar at I plus 1, this correlation is greater than 0. So correlation, which is also written as with the Greek symbol rho, Greek letter rho rather, is a number that's not 0. This one and this one are the same thing. So this is the Greek letter rho. The Greeks have a lot to say on this page. My introduction to the history of art professor in 1975 at Cal State LA said, in his opinion, old guy, in his opinion, there had been no new thought since the Greeks. So correlation is a number that's between 0 and 1. But how can you have the correlation between xi and xi plus 1? What sense does that make? Well, this is the same process. It's just at 2 time points. 2 time points. 1 step apart. And 1 step apart means, damn, lag 1. People use the phrase lag, the word lag, to mean you, and in this case, you're lagging forward. So you're not lagging behind, you're lagging forward. See, because it's I plus 1. But the same correlation would come out if you worked x sub I, comma x sub I minus 1. But this is the same variable. Well, yeah. See, it's self. It's the same variable. So it's correlated with itself. That's the idea of autocorrelation. This is a big deal with control charts, because if we have highly correlated data that we are observing to build and to keep our control chart, then this autocorrelation is going to mess with our control limits. And we can't have that, because then we'll have the wrong false positive rate, either too low or too big. But anyway, we won't know what it really is. We'll be thinking it's 0.0027 when it actually isn't. So autocorrelation in XI process time series can cause control limits to produce an unintended false positive rate. It's a nice way of saying an unknown false positive rate. So we have a problem if we have autocorrelation. So we have a problem if there is autocorrelation. So I guess the first thing to decide is whether or not we have autocorrelation, because if we don't have a problem. Everything I've set up to now will work just fine. Which implies that everything I've set up to now assumes that we have no autocorrelation. The row from between two variables just one step apart, that correlation is 0. So I guess the first order of business is to test for autocorrelation. So I'll say first order of business is to test for autocorrelation with, you guessed it, stage 1 data. So you go into a doctor's office and you're complaining of something, or you get a good job and you can finally start afford to going to a doctor regularly. And what do? They say, well, we're going to run some tests. Well, why are you going to do that? Well, we got to find out the baseline. We got to find out the nature of your physical state. We're going to do blood pressure, we'll do blood work, a whole bunch of tests. Same thing here. What's the other tests that we've been working on in here? Answer, you want to do a normal QQ plot of the X bars in stage 1, because if you have lack of normality, you've got another problem, and you're going to have to do something about it, either increase the subgroup size, or if management says you can't do that, then you're going to have to come up with some sort of a transformation. So we have a problem here. We need to test for autocorrelation, but we don't know how to do it. compute an estimate of the lag 1 autocorrelation. If you've ever had your blood work done, you notice that it happens real fast. They take your blood, and then in the morning, and then in the afternoon, boom, they know. They know what? They know like 30 things. So obviously they've automated the blood test because they're not doing a manual test on each one of those things. Clearly they've got a machine where the blood's put in it, and boom, 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 all these tests get done. That's exactly what you ought to be doing with control charts. Is you ought to have some sort of a script that checks for normality, checks for autocorrelation the minute you gather initial data on a new metric that you need to design control charts for. So you just run the script and a whole bunch of tests, these two and others, as you get more advanced, to get a handle on the nature of the beast that you don't have experience with yet. So what we're going to do is an estimate of lag 1 correlation. And we're going to call it creatively row 1 hat. And it's equal to this. The difference between each subgroup mean and your best guess of the true mean, x double bar, multiplied by x 1 step back, centered at 0. Same thing, but now we're 1 step back. This whole thing divided by the sum I starting now at 1 up to k of xi minus x double bar quantity squared. If row hat is small, then you don't need to get all worried about it. So if row hat is smaller in absolute value than half, then autocorrelation can be ignored as a rule of thumb. So how are we going to do this? Test. Because this formula looks pretty intimidating, doesn't it? Well, we're not going to do that by hand. We're going to use SAS. So let's see if we can get SAS to do this. Test. On a baby data set. So I've written an example. And I'm going to use SAS's time series functionality to get this test. So let's see. Get to the G drive. Find me. And up here is auto core check. Pretty simple example here. Most of it is the data step. So what do we have going on with the data step? We have two columns. The first column is the time value, and the second column is the x vertical axis value. And we don't tell it how many; it just counts as it reads data. Here come the data lines. At time 1, x is 2, and so forth. And then end of the data set. Then we have procedure autoregressive integrated moving average. That's what ARIMA stands for, or ARIMA as people call it. Now in my business forecasting course 713, which is an MBA course, and it's also a course for the certificate in analytics, business analytics, I spent a lot of time on PROC-ARIMA because it's all the rage in business forecasting, in particular finance and demand for a product, consumer demand. But we're going to use simply the identify procedure option rather in PROC-ARIMA on the variable x read in as a time series in order to compute the estimate of the lag 1 correlation. So let's run this guy. So that's auto core check in my G drive. So it's running, connecting the server, running PROC-ARIMA, collecting, and hopefully here in a minute we will get a picture. And sure enough, let's get rid of all this nonsense. And what do we got? Well, we have the average 7.3, standard deviation 4.1, and we have 10 observations. And we have lag 0, 1, and 2. So lag 0 is nothing more than the variance. And of course, at the same time point, the variable is perfectly correlated with itself because you're not stepping forward or back at all. And here's a little bar chart of rho at lag 0, lag 1, and lag 2. We're interested in lag 1, and we get a correlation of negative 2.77, a covariance rather, and a correlation of negative 0.165. And so here's the value 1, star, 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 make a little bar in line printer talk. And then through the little stars in the negative direction to give us the value negative 0.165. So by our rule of thumb, we declare that we're good to go because the absolute value of the lag 1 correlation is much smaller than half. So we can, according to the rule of thumb, ignore the effects of autocorrelation on our control limits and hence our false positive rate. Here's a lecture question for you. And that is, please use please use SAS and that file was auto core CHK, use that as a starter to compute the lag1, the estimate of the lag1 correlation for the wheel hit data that is used in the SAS file chart1.sas. So use SAS to compute the lag1 autocorrelation for the wheel hit data that was mentioned in chart 1. And tell me what the autocorrelation is that you get for lag1. Okay, well, Professor Laith Alwan my colleague in the SCOM and Business Statistics group, wrote a dissertation at what a lot of people consider the either one or two best business school in the country. And what did he write his dissertation on? Rho hat bigger than 0.1 can cause significant changes to the false positive rate. So you can say, oh, nobody studies control charts anymore. How boring. And irrelevant. Professor Alwan wouldn't be on the faculty here if he had not written his whole dissertation about control charts, and in particular the dangers of running a control chart when the autocorrelation lag 1 on X bar is bigger than something even as small as 0.1. And he gets invited to go over to London and speak to an international audience of business and manufacturing statisticians about his research. He followed it up with a number of papers, and he earned tenure here. He's one of our senior people in business statistics. So it's a much studied problem, and it can really play havoc with the false positive rate that you think you have, and in fact you don't have it because the correlation has messed it all up. What to do? So I'll say what to do if autocorrelation cannot be ignored. A simple fix is to use advice in Ryan. Gleaned from work by Michelson in 1994, and most particularly Zhang at the National Institute of Standards and Technology in 1997. So there's another heads up. So who's using a lot of quality? Answer, the Department of Defense. And who is one of our, which agency, or if any, is an agency that does a lot of work in statistics? Answer, the NIST, as it's called, the National Institute of Statistics and Technology. There are a number of statisticians there, and they're working on business problems to make U.S. businesses more competitive. That's their charter. So in the screencast one for next week, I will give a suggested procedure for dealing with autocorrelation that you can get out of Ryan, and also by reading these two papers. But I'll condense all these ideas into a screencast with a lookup table that you can use. And I'll have a few more comments on issues with autocorrelation before I dive into individual observations and attribute data control charts. That will be the main focus of next week. End of screencast.